Today we're talking about Go, writing Pulumi code in Go, and we will do this on AWS. So just shortly about me. Yeah, my name is Engin Dili. I started last year as a customer experience architect at Pulumi. Worked before in different places. I'm based in Germany, so I mostly worked in German companies. And one of my strong areas I like to work on is cloud transformation, cloud enablement. And as you can see, there are some social medias you can follow me. X, not Twitter anymore, Instagram for some pictures. And yeah, just follow me if you would like. Today's agenda, a little introduction. I would like to give everybody the chance to catch up on Pulumi. I promise I will keep it very short because maybe some of you already worked with Pulumi and I know the stuff. But again, it's always interesting to see how Pulumi is working under the hood. This is then again with the high level view. Again, it's a very high level view. And then we already switched to the Go part. And we talk a little bit about Pulumi Go, what is the state currently, and some of the cool future improvements we have planned for the Go part. And then, of course, we will dig into the workshop and see everything in action. Okay, just a short introduction again about Pulumi. So these are our 3 pillars. I love this slide. This slide is really on all of my slides also when I talk to customers. So I divide them into these 3 pillars. And we have here, first of all, the build part. We have a huge selection of languages. Today, we're going to focus a little bit more on the Go part. But again, you can choose your language depending on your company. If you have a polyglot company, people can use the language they are more familiar. And also we see the integration into IDEs. Pulumi is not inversive, so you can use it in whatever system you would like to use it in. IntelliJ, I, for example, use IntelliJ. I saw people using Vim, for example, also to program Pulumi code, so that was very interesting. The middle part, this is where the magic is happening. We have here all the providers, which are very... The speaker takes a lot of space. Oh, okay. There's good feedback from you. Let me see how I can change this. Is it possible to... Okay, is it better now? I should be not in the view anymore. Okay, so just the middle part again. Okay, so the middle part is where all of our providers are, where the magic is happening. We have here the major providers, the major cloud providers, AWS. So good, perfect. AWS, we have Google, we have Azure. We offer this provider also with a native provider. So you will get, for example, in our Azure native provider, you will get all the functionalities day one. So instantly something gets added on Azure side, you will be sure that Pulumi will also offer this. But again, you have also plenty of other providers for different SaaS. So this is really cool to create your perfect Pulumi program. And the right side, we have the way how to handle a Pulumi program. We can use whatever CI system we have currently in place. Most of our customers, for example, have GitHub and GitHub Actions in place, but also Azure pipelines are very common, Circle CI, you name it. And the latest thing I saw from some customers was also even using Tecton pipelines, so you can be a very Kubernetes native also. And then again, storing most of the most common storage possibilities, or the version control systems like Git is supported. We have GitLab support, so on this side also everything. So normally no need to change anything when you introduce or when you work with Pulumi. This is very nice. Okay, as I promised, again, the high level view, just to have an understanding how the Pulumi architecture is working. So this picture is also something we show on a quite regular basis. This is the architecture. And as you can see, we have our CLI, we have different providers, and how do they play together? So first of all, we have our language host. When you start to write a Pulumi program, in our case in Go or in Node.js or Python, in the background, when you run a Pulumi app, Pulumi understands which runtime we are using and starts for the first microservice. Pulumi Complete is a microservice architecture. One of our engineers already told me also Pulumi is a microservice architecture which accidentally runs all on one single host. So first service gets started, it's our language host. Then of course we have our CLI and engine. This one gets created. And then depending on the provider we are using, the appropriate provider gets started. So in this case, we're going to use the AWS provider. So Pulumi also downloads the binary, if not present, from GitHub, starts the service, and then communicates via gRPC to do the commands like create, update, and delete. This is the place. So you write your code in the language host, it gets translated. Then the provider gets started, we do our operations, and as a last step, the state gets saved in a state backend. And here you can see we have different, I have to press pause, it doesn't slide forward. We have different backend possibilities. Of course, we have the Pulumi service or Pulumi cloud, where we take care of your service. It's completely free for OSS users. There's currently not that you have some limitations in terms of how that you have to register or put a credit card in it to use the Pulumi cloud, to use the Pulumi service, but you still have the option to use also an alternative cloud provider, for example, S3. I saw that we have also an Artifactory support if you want to upload this, or you can use your local file system and save it there. So there's much possibilities here. How does a typical Pulumi program look like? That's also very interesting. So a Pulumi program or a Pulumi project is everything underneath it keeps on swapping. Everything where the Pulumi YAML file lies in, where we have the definition of our Pulumi program, where we define the runtime, the description. We will see this later in the demo code or in the workshop. So this is the Pulumi program. The second part here is the stack. So we can create for every Pulumi program, we can create stacks. Most of the time people using the stack with dev, QA, and prod. But you can also use whatever naming convention you have in your company. We see people, for example, using stacks also to creating ephemeral environments. So they have some alphanumeric number, which is not making sense for a human. But as it's an ephemeral environment, it gets deleted afterwards. So yeah, here in this case. But again, most of the people using the stacks with dev, prod, and whatever your staging system looks like. The next part, we have the resources. This is our smallest building blocks. This is really the Lego parts where we put stuff together to say, okay, this is our S3 bucket, and then we have our EKS, for example, or our VNet. So we can then build from these blocks our program, our infrastructure we would like to deploy. So this is the part. Every resource, of course, has a way to modify it, to adapt it to our needs. So these are the input and output. We can define the input. We can say, hey, please create an EKS with 8 clusters or 10 nodes, up to your requirements. And every resource has also an output. For example, in our EKS example, it generates as a kube config. This is one of the most used outputs we know, because we want to donate this kube config maybe to our development team, or we want to use it programmatically to deploy applications, to deploy Helm charts, whatever we need. So this would be an output. And now comes also one thing, you can use the output of one resource as an input for another resource. So using the AWS provider to create your EKS, using the Kubernetes provider, and then telling, for example, hey, Kubernetes provider, take the kube config, the output, and just use it for further operations, for example, deploying Kubernetes deployment or a Kubernetes service. And then, of course, which is very, very interesting also, projects can have input and output on their own. So you can create a project and tell, for example, okay, this project exports as a whole because it does a lot of magic inside. And maybe me as a developer, I don't care how you set up the perfect EKS. I just want to get the kube config. So I can order this internally via my developer portal or via my ticketing system. I can say, hey, operations team, please create for me the EKS cluster. You take care about this. So they deploy the Pulumi project and they just tell you then, this is the stack name, and then you can reference it. So this is one functionality of Pulumi, that you can reference inside that Pulumi project. You can reference another Pulumi project and just access the output values of the other Pulumi program. This is very, very useful if you want to have some kind of separation of concerns and say, okay, I'm not owning the Kubernetes cluster, but I'm owning, for example, every application deployments on top of it. So I'm only taking care of the deployment and taking care of just consuming the kube config. Okay, so this is so far the Pulumi high-level view. If you have any questions, feel free to enter them into the chat. I'm happy to answer this. So Pulumi Go, the Go SDK support. I use Go mainly. So for me, Go is my main language I'm using for every Pulumi program I'm working on. And I can tell you that Pulumi really loves Go. And the reason itself is, yeah, Pulumi is written in Go. So the CLI, for example, or when you see some of our provider projects and so on, they're all written in Go. If you want to write your own Pulumi provider, it's written in Go, for example. So you can just use one of our templates and then create inside using Go your own provider for your company, because you say, hey, we have an API. Okay, so okay, we get the first questions in. Very good. Pulumi, as I said, supports every supported Go version. So if you work with Go 1.18, for example, you can use this. There is no need, if you are not allowed inside your company or you just don't want to upgrade, you can still continue using the version you are approved to use. So from this side, there's also no limitation. It's not like that the Go support runs out for an official supported Go version from the Go community. We have plenty of templates, Go templates. I will show this also in the workshop where you can just kickstart your infrastructure journey. If you say, okay, I want to use AWS Go, for example, you will get a template and then you can easily start to work with this template. Very good for some cookie cutting. And last, because I put now here 99% that all our Pulumi providers support Go. I didn't check all of them, but the ones I use since years and every day, they have all Go support. Maybe there's one provider which doesn't have a Go support or a Go SDK generated, because you can decide when you create a Pulumi provider, you can decide in which languages he should generate SDK. So I'm not sure. Maybe somebody says, hey, I don't want a Go SDK because our customers, they don't use Go, but everything you see in our registry should have Go support. Okay, so, and the promise, the last slide before we go over to the workshop is what's next. So one of the big things we are working on currently, and you can participate, I put the QR code also there, is generic support in Go. Everybody who worked with Go knows that the latest the one, I think it was 119 or 118, Go generic, Go support generics, and one of the big things is that we want also to support them. There is an RFC open, you can participate, you can comment on this, you can share your thoughts on this one. So highly recommended to check out the discussion page and give our engineers feedback and yeah, be part of this cool new feature we are working on. Okay, before I continue to head over, let us quickly see what are some of the questions. What would be the different use cases for using Pulumi over Terraform? This is one of the most asked questions, and now you get my point of view. Of course, I'm biased because I'm working for Pulumi, but I would say it really depends your use cases. So most of the time, what we try to say is, okay, let us think about your use cases, see what pain you have with your current setup, what is the limitations, and how we can help you with Pulumi to create more value. That's one part. The other part is, as you see, you can use a programming language. We have a module called the Pulumi Automation API. This is something most of our customers are really using. It gives you the ability to programmatically execute Pulumi code. So you could create a backend service, you can create a Kubernetes operator, you name it, and use the programming language you wrote the service to execute Pulumi programs. This gives you a really nice ability. I saw, for example, customers creating their own CLI where they execute, for example, Pulumi stacks. They used it for ephemeral stacks for the developer. So the developer downloaded via Chocolatey the CLI, and then they could create ephemeral environments via the CLI. So again, maybe not the most satisfying answer, but yeah, it depends, and it really see what are the plans, what you want to do with the infrastructure as code. Is this good for a beginner? Charles, do you mean the workshop, or just let me know what you mean with the question. Sahil asked, can we have one project that sets up infra and other facing the developers for code purpose only? Yes, that's what I mean, if I understood your question right, that's what we do, for example, or I prefer to do. I create not anymore some monolithic stuff, but so-called microstacks, what we called, to say, okay, one stack written in Go, whatever, is really for the infrastructure. One stack is for the application. Sometimes customers also cut them on the velocity of the different stacks. Say, okay, a VPN, a network doesn't change that much, so we put this into one stack, and application services or services with a higher changing cadence, they come into an own stack. So yeah, it makes absolutely sense to when you start modeling your Pulumi structure, to also say, okay, how are we going to cut this? And if developers, for example, are completely right to deploy on Kubernetes, it's very cool to then just give them the kubeconfig via the stack references. How about Python support? Is there a DSL with Pulumi like HCL for Terraform? So yes, we have Python support. So there are many workshops already made from my colleagues about Python. We have plenty of customers who are using this. The only thing, I mean, we don't have a DSL at the moment. What we are offering is, for example, YAML. So you can use, for example, YAML or Q on top of it to have, if you're not want to use a generic purpose language for the moment, maybe your company is not ready currently, and you just want to start the story. One advantage is when you're using the YAML language from Pulumi, the YAML support, you can then convert it into a language. So your work doesn't get lost when the team decides, hey, we want to go with Go. You can just say convert. Yeah, Bruce answered this. So yeah, true, Python is supported. Yes, the magic Lambda functions, I'm not aware currently. I was always under the impression that this is currently only something we support in TypeScript and JavaScript, but yeah, I can check on this one. There are guides, Luis, on our website. I put the link for the components. Let me see, where is it? It's our Pulumi plugins. Just our framework. I need to look up the address. It's on our GitHub page. Just look for our provider. Just type in the search bar provider, and you will see a repository where you can template, and then you can create your own repository out of it and can start with it. I also created a native one. I can share this also in our repository. Charles answered, and there is it good for beginning somehow? We're just starting in IT and who is not very knowledgeable. I mean, if you have a programming background and you already are familiar with a programming language and you say, okay, then you can just pick and start. The cloud provider you have to learn. I mean, this is something you need to understand how the provider is working. Every cloud provider has a different approach to provision their resources, or how they think a Kubernetes, for example, has to be provisioned. But from the starting point, as I said, you can start with YAML to say, hey, we are not decided now which language to choose, so maybe we just need to ramp up our language skills. You can just start with YAML, so I would say absolutely. How is it handled a state when multiple members are working in the same Pulumi project? Then he asked this, Pulumi has the concept of logs. So a state get locked when somebody else is working. So if there's a situation where several people committing on the same project, on the same program, there's the concept of log. Okay, so far with the questions, then let me show you the demo that we have a little bit time also for the workshop. So it's a very simple demo. I just want to show you some of the basic concepts and give you an idea to just play around. So the idea is, yes, step one, we write Pulumi, we write a Pulumi project, and then we deploy a Lambda, AWS Lambda, very simple. And then, of course, the whole IAM stuff. I mean, this is, again, and science on its own, but yeah, we create the Lambda and we create the IAM roles for it, the IAM policies. This is going to be step one. In step two, we're going to deploy an API gateway. So we're going to register the Lambda to the API gateway, or the API gateway as trigger for the Lambda. That's very interesting. And last but not least, to give it a little bit, another twist, the Lambda itself will then read from a DynamoDB. So in step three, we're going to deploy a DynamoDB and then tell our API gateway call, which then triggers the Lambda to read out the table and print out some informations. So a use case people I encountered very much if people working here in the serverless area, and that's going to be cool. So I stop screen sharing for a moment and open my browser. And while this is happening, I also sent some of our polls out, so you can just enter. Because I'm very interested in to learn a little bit more about your use cases, so I just sent out. So far, that's okay. Now, okay, let me share my screen. So where are you? Start. Okay, so everything starts here in the console. So I just make the link for the workshop is in the message box. It should be everything there as a sticky note. So feel free to just click on it, because this is the thing we're going to use. So, and I make the same. Let me go create a temp folder. Come on. So we call it workshop, and then we can take out the workshop. So I just clone the repository And then inside this, it's called Pulumi. Okay, that's our Pulumi AWS. And then we can see here, everything is checked out and the demo code is also there. Okay, then let me start the next screen. But as I said, I highly prefer to use IntelliJ. And I will share now also my IntelliJ screen. So then let me share this one. And share. Okay, so everything starts here with the README again. If you want to try this on your own afterwards, I also mentioned every step. So when we go here in our workshop MD, we can see again the graphic and the single steps we want to do. So first, what we're going to do is we will start a new Pulumi project. So we see here with Pulumi new, I hope it's big enough, with Pulumi new, because somehow scrolling is not allowed in IntelliJ to make it bigger. We can create now our Pulumi project. The second part, the AWS -go, it's for using a template. So I say what I mentioned before, and I will show this also here in the browser when we and we create now the project folder. And if I say Pulumi new, without typing anything, I will get the list of all the templates we are supporting. You can later on also define your own templates as part of your cookie cutting process, put it into a Git repository, and then just tell the people, hey, this is our golden paths, and people can just use this here. The ones you see are the inbuilt ones we providing, and then you can start typing and see everything Go related. And this is what I put on the slide also. There are many templates already in place. So what we're going to use is we will use the AWS Go. So this is a minimal Go program for AWS. You can either select it here, or what I also prefer is, and this is what you see in the documentation, when I know which template I'm going to use, I just type the template in, --false I use because I already created the folder. If I did not create the folder project, I would not need the -false. And now we come to the situation. It asks me now, hey, enter some informations about the project. It's a wizard. So we can say, hey, it's our AWS workshop. So enter this. We can write a description. Workshop code. And then what I mentioned before, the stack name. So it always comes up with your dev stack. You can name it accordingly what you're trying to do, for what you want to deploy this. So in our case, I led it with development. Now I can say which. This is now part of the cookie cutting process, because you can define in your template some config parameters. The Pulumi new process will ask for. So you can really make a wizard where people just have to enter some of the properties they are allowed maybe to change. So here in this case, I will deploy to EU Central 1 because I live in Germany. And yeah, everything gets installed. So now we can look up the definition. We see here we have now a project. So inside the project, let me activate my Go support. So inside here, we get everything as we are used to when we work with Go. We get our Go mod where we can define the libraries, the versions of the libraries. We get already a pre-filled main Go where we can where there's already a bucket. So this is part of the templating. I used the minimal one, and our minimal templates have always some kind of bucket inside. We don't need this, so I will instantly delete this because we're going to start working with our stuff. What I then like to do is I like to update the modules. I like always to be on the latest one. So that's again, this is now something Go specifica. Go get update and go more tidy, and it should give us now nicely the latest version of every dependency we have inside. So here our AWS SDK and our Pulumi SDK should be when the internet connection doesn't. Yeah, perfect. So everything is there. Perfectly fine. Now let's see how we're going to continue. So this is what I said. We start with our empty shell here. We don't need the bucket currently. So one of the first steps is now we would like to create the function, the Lambda function. So no, we're not going to create now the function code itself, because this is not a part of the workshop here. So what we can do now is we just use the one I provided here. So I create inside my project to show, okay, the application code lies also there. Again, this is something you can also organize differently. I just created here the function folder, and I create now an index.js file because we want to write the Lambda in JavaScript, because maybe it's a different team who created this and owns the code. That makes sense here. And we just copy paste here the content. So when we look at it, it's a really, really simple Lambda. It just has the signature for calling the Lambda and the event as a parameter. We look for a query string, the user ID, and the game title, because we would like to create a high score service here. And then we just return the value of the found entry in the database. That's all, nothing else. So we're not really looking to make this even better. And as you can see, when you're a seasoned developer, you already spotted this. Here's no error handling. So if we don't send any string parameters, this Lambda will hard fail. But again, that's not a part of this workshop now. Okay, we created this one. And now comes the first parts where we have to write our Go code. And our Go code we're going to use consists of the first part is creating our Lambda, our IAM policy, because or the policy we would like to create. So here in this case, we want to give you the assume role. We want to allow the principal of Lambda, the service Lambda Amazon AWS.com, that he has access. And for this, we need just to create this resource. Here I created it here as a JSON, because the property, the new role, gets the JSON inside. And let me, so the role gets created, and then here the real part is creating the function. So we use a helper function, some syntactic sugar from Pulumi, to create a zip file, because in this case, we don't have here the magic function we have somebody mentioned before. So we need to get our application logic of the Lambda as a zip file. So we can use here the syntactic sugar of Pulumi new file archive. We just point to our function file. We give it a name. We now pass one output of a resource, in this case the ARN, to the next resource I mentioned before in the graphics. And yeah, that's it. So let me copy paste here the code, because copy pasting, it's always good. And of course, we're missing some of the come on, sync this, sync dependency. So, okay, that's fine. We just import the JSON part also. And now we finish the first part. So what we can do now is, I just need to log in. that we get the credentials, that I'm allowed to log in. Again, for a productive environment, you would go with an OIDC provider, for example, to have a passwordless authentication with your cloud provider, or maybe you get the credentials. Maybe they are also part in your CI/CD pipeline. You have it for dev, but prod gets deployed via a CI/CD pipeline. So this is something also depending on the process on your side. Here in my case, I just use the single sign-on, and I will get then my credentials. And now comes the first part. Put this a little bit up. We can now say the famous Pulumi up, because we want to deploy now our code. And what Pulumi is now doing, again, what we saw on the graphic, it detects which provider to use. It starts to communicate with the providers. Here in this case, first phase of the Pulumi app is always a preview. You will see the changes at the cloud provider, or what will happen with your code. In our case, we don't have anything deployed at all. So everything is a create. We see here the output. It's marked here as output string. This is some properties you get only the feedback when it's already deployed. So this is something Pulumi cannot calculate because it's something on the cloud side. So it will just tell you, hey, there will be a string coming, but I don't know the property currently. So we say yes, because we are happy with this, and why not, YOLO? And everything gets created. Thankfully, it doesn't take so much time like some other resources. And we should see that in a couple of seconds. Normally it doesn't take that long, that our Lambda is created. Perfect. So we get here some of the properties. Again, I can export whatever I want. This is the state, the CTX export I mentioned before. So my program here is exporting the ARN. So I can reference this in another stack. Here in this case, I just put out with the dot. I can just export whatever I need. So in this case, I just took randomly here this field. Okay, so our Lambda is deployed. We are happy. Nothing broke down. That's very good. So we can head over to the next part. Again, in the workshop text, I also made some text about what's going on. The Pulumi preview we did, everything is fine. So let me quickly change the view that you can see also. Okay, so I stop sharing this one, and I will share now the view of our provider of the management console. So here we can look now. I logged in into my console, and where is it? EU Central 1. We expect now here. Here we have our high score. So everything is deployed. We can see perfectly fine. So stop sharing, and we can continue for the next part and say that's not all, because we would like to deploy more. So let's go to the API gateway. So again, we just annotate now here in this workshop. I did not split now here into different stacks, because for this scope, it doesn't make sense. We create our REST API. We create the appropriate resource for it. Everything is API gateway related. That's what I mentioned also before. You still need to understand how the cloud provider is working, how to set up an API gateway. So here, these are the properties we have to set. The method, we define a get method, because we want to read the high score for a specific one. So it's a get we created here. And the integration. And I created the first stage here in my gateway. I called it test. This is all AWS specifica. So in this case, this is you have to know, and you have to talk with, maybe when you do the architecture, or with the architect in your project on, hey, what's we going to do? How are we going to set this up? Important is that we have to set the permission for our Lambda. And now I copy the next part here out of it and say, okay, so let's do this. Now we import the API gateway, that's fine. And we can now again say Pulumi up. And we should see now only the difference. Oops. Okay. I have the config in because I would like to read out in some fields I have to get access for the AWS region, and the AWS region is defined in my stack. So here, this is configuration only for the dev stack, for example. So you could say for the prod stack, for example, use a different region. And I would like to read out the region. And what we can see now with the next preview, we see the only changes which will happen is the new creation of our gateway of the permission. The old resources we already deployed are untouched. So we can update this. Just something to mention, I do this now step by step. You could also write everything into one code. So it's just because I do the demonstration step by step, doesn't mean you can just Pulumi up of the whole stack. Pulumi will sort the resources and will create them in the right dependency. I just want to show you here how things are going. So we created our API gateway. We get an endpoint also. We can see the stages encoded. We get here the Amazon URI. Of course, you can also create your own domain on top of it. And then we have the endpoint we just created with the high score. So let us try how this is looking. So we say curl, and now we expect also to get an internal server error. Yes, of course, because we don't have a database currently. And the Lambda will just die miserably because I even don't do any defensive programming. But we know everything is working so far from the two parts we deployed. So we can continue. Again, I put more text. If you're interested to get a little bit more about the resources, feel free just to check the demo code. We did the Pulumi up on this one. And now comes the last part. We create now our DynamoDB. Here I create a table called high scores. I define the hash key and the range key. The good thing with DynamoDB is a schema-less, so everything I define on top of it, I don't need to define here in this situation. So yes, of course, user ID and game title is not a high score stuff, but yeah, the top score we will put later on because it's a schema-less database. Again, because it's AWS, we have a lot of IAM roles going on because the Lambda and the gateway and everybody has to talk with everybody and we need to give the rights. So that's the reason we create here a policy, and we create the policy attachment to say, hey, the Lambda is now able to read, and in this case, really get item only. So the action is really get item. So our Lambda is now allowed to query the database just for get items and only read-only access. This is what I configured here. And now we can take also the last part of our demo code and enter it here. We can check that the library is also imported. Yes, perfectly, everything is fine. Let us put here a space to get the linting perfect. And as you can all imagine, we can now say, for the last time, we can say Pulumi up. And hopefully we only see as a preview again, we only see the creation of the DynamoDB table, the policy and the policy attachment. That's fine. We want to roll out this. And it also takes a couple of seconds. And we should have our, yeah, perfect. So perfectly fine. And how are we going to test this now? So I also created some ways to test this. Pulumi up with it, that worked completely fine. So if we ask now for a game, the high score, so in this case, I say the game Halo, and we use for the user 2. So give me the high score of user 2. That's of course the wrong one because the one in the demo doesn't work. So just copy and paste this stuff. And we get nothing. Yeah, that's expected because the database is empty. There is no service running to pre-fill this. So yeah, that could be something going on, a queue or whatever, getting informations out maybe from our running game, posting it into the database and having then our website or whatever service calling this endpoint to display the stuff. We see a 200. So at least we don't have an error anymore. So let's fill some data into it. So in my case, I use the AWS CLI to just enter a new high score. Let us use here this one here. So that's fine. And if we do another curl, we expect now, and I use a JQ now, and let us make it silent. I don't want to see all the stuff. Perfect. We get now the result back. We get now the high score for a user for a specific game. So if we add another game to the next player, so then what could we take currently as a game? So let's take Minecraft. We check now for Minecraft. Perfect. We get the high score of player 2 in this particular game. Very cool. So far for creating the demo and creating the content. And of course, we are a very good cloud citizen, and we say we don't want to let anything up and running if we don't need this. This could be also part of your ephemeral work. So as I said before, you could create now a specific way backstage or whatever to create an ephemeral environment. And at the end of the day or whatever rules set time to live you have, you could just shut them automatically down, saving on cloud costs and saving our. So Pulumi destroy. Again, I could call Pulumi destroy. I will get a preview of what gets destroyed and so on. In our case, we know that we just want to destroy our demo environment. So we can just say -y and -f. Because here I don't need the question, hey, I'm going to delete this, and -f means, hey, force it, brute force your way through. So you see, this is what I would put, for example, in a CI process where I don't have any interaction. I would say Pulumi destroy -y -f. Or if I want to spin up everything and I don't want all the time to get to ask me, because again, it could be part of your CI process, I could also say Pulumi up -y -f. And then it will start again to spin up everything for me. As you see now, he creates all the resources and the sorting. You see, Pulumi in the back end, in the background, does the sorting. It will create a graph for you and brings the resources into an order where he says, okay, anything which is not dependent from another resource gets created parallel. So that's why the reason you see the DynamoDB in one of the first places. And any dependencies get automatically resolved, and Pulumi can then spin up the stuff fairly quick because it can highly parallelize the creation. And here again, we have now our new environment spin up. That's fine. Last but not least, I show you also how to create a second stack. We have here the command Pulumi stack. And I hope so. And then we can here see where was it? Pulumi stack. Let us call it. Okay, so we created now the second stack, our prod stack. And as we can say, for example, we don't want that our prod stack gets deployed in, for example, in the EU central region. We could just set then now the, we select the stack. prod select prod. Sorry. Okay, now we selected the stack, so we can also say Pulumi preview. And he gives you also, you see, he would create now again for a second stack, he will create the resources, and then we have a second stack and can also change the properties here. So that was the part to show you how to create the different stacks. How to select them. Of course, this is also something you can do via CLI. So the -s for example, if we say Pulumi up, you can see here with where is it -s, you can give the stack name. So everything is programmatically possible in your CI process, no human interaction needed. Okay, then I stop the screen sharing and open again my camera, and we can go to some questions. While I browse through the questions in the last minute, I sent the last poll of some serverless question because I found them very interesting. I think you should have now all the feedbacks, and now I can look up in the chat for some questions. So H. Kraus found a comparison site, very cool, with Pulumi and Terraform. Maurice asked if we are using Go to create the function code. Would you need to split this project? That's what we said. I need to check this one when you create the function in Go. So Alberto drops. Thanks that you joined the call. If you watch later, appreciate that you joined the call. Are there any project or example reports you can point us to which show how nice ways of abstraction the code? Yes, there is something. Let me put this here. So the Pulumi template. So highly recommend that you check the Pulumi template page. You can see some of the templates. And then we have our blog series. Scott Love and Christian is working on this. It's called the project Sapphire. They created an imaginary company and explain around this. So that the storytelling goes, there is a company called Sapphire, and they start the journey. So you can learn with the company. You can also learn and see what did they do, what best practices we are suggesting here. So there's a whole series going on this one, and yeah, you can just follow this one. Of course, join our Slack. We are there in Slack. The engineering me and everybody from Pulumi is quite active in the Slack. If you have any questions, feel free to reach out. And Tim asked, I assume we can use this for more than just lambdas. You mean Pulumi? Yes, of course, you can deploy everything. You can use templates for everything. If the question was for the templates, and if the question was for Pulumi, you can use Pulumi also to deploy your EKS, to deploy your Kubernetes deployments on top of it. Or what I do sometimes for some Minecraft servers, just to deploy a VM, a EC2, or whatever provider you're using. That said, thanks that you joined the call. And yeah, play around. If you have any questions, feel free to reach out. And I hope you enjoyed it so far. And you could see I was quite excited. It was my first one. So thanks for all.